So let's pretend you have a buddy from school, whether it's high school or college, and you're graduated, and he comes along one day, and you run into each other, and he says, "Hey, I've got a great deal. Give me $10,000. Okay, that's your principal investment. And he's going to offer you $15,000 in return in 10 years. Okay, let's assume you can trust him for whatever reason. Maybe this is not a good idea in general, just giving people $10,000 that you once knew in school, but for the sake of the math problem, let's figure out what the actual interest rate would be, right? I'm talking about R, the interest rate, of an account where you put in $10,000, you get $15,000 back in 10 years. I want to know if this is a good interest rate or not a good interest rate, so we can decide how to invest our money. So the calculation that we're going to do is based on the formula A equals P times 1 plus R over N to the NT. That's our discrete compound interest formula. And this compounding schedule is pretty good, actually. It's weekly. Okay, remember, the more often you compound, the higher the return will be. So let's start plugging numbers in here. A, remember that's the amount promised, is $15,000. P, the initial investment, is $10,000. And then here's the rest of it, 1 plus, we don't know what R is. That's what we're trying to figure out. N is 52. And in the exponent, you have 52, the number of weeks in a year, times the number of years, 10. Okay? So the way you solve this is just, it's like PEMDAS, or push Elvis's mother down a sewer, right? It's the order of operations. You just want to figure out how to unwrap R. We're trying to get at R, and you've got all this other stuff on top of it. So just try to peel things away as you see them ordered on the outside of this equation. The very first thing that I'm looking at is this 10,000. If I can get that off of there, that'll be a good start. So I'm going to divide each side by 10,000. 10,000, 10,000. And what you get is 1.5 equals 1 plus R over 52 to the, looks like 520. That's a big exponent. And now, you might not know how to deal with that exponent. Think about it this way. If I said x squared equals 4, we all know how to square root each side, right? Square roots get rid of squares. And in the same way, there is a kind of radical which will get rid of a 520th power. Okay, let's put that right here. 1 plus R over 52 to the 520th power. We want to get rid of that exponent, but it's not a square root. It is a 520th root. And if you don't know where that button is on your calculator, what you can do is a different sort of calculation, and that is 1.5 to the 1 over 520. The fraction 1 divided by 520 is like saying the 520th root. So I'm just going to punch that into my calculator here. 1.5 to the 1 divided by 520. And that equals 1.00078. Okay, and that's equal to 1 plus R over 52. And at this point, the calculation should be straightforward. I'm going to subtract 1 from each side, and I get 0.00078 equals R over 52. And then I multiply that by 52, and I get R equals 0.04056, which is about 4.056%. Okay, that's your interest rate, which is not great. It's not terrible. Your buddy's not trying to rob you blind, but he's probably earning 6, 7, 8% off of your money and then giving you 4% instead of the 6, 7, or 8%. So he's making a good deal too. Let's try this for continuous compounded interest. We'll use all the same numbers, and we're just going to plug this into a PERT formula. So we'll say 15,000 equals 10,000 E to the R. I don't know what R is, but I do know that the length of time that we're waiting is 10 years. Okay. So again, we're going to divide each side by 10,000. I get 1.5 equals E to the 10R. I'm going to take the 10th root of each side, And let's see, 1.5 to the 0.1 power, that's the 10th root. On the left, I get 1.0414. And on the right, I get e to the r. So to solve this, to figure out what r is, we're going to have to do a logarithm of both sides. Hope you remember what logarithms are. Logarithm of 1.0414 equals logarithm of e to the r. And a wise choice in base would be e, because that's going to cancel things out on the right nicely. The log e cancels out the e, and you're left with r by the power rule. On the left, this is a calculation you can just plug into the calculator. That's what they're for. So I'm going to say that equals, let's see, calculator says 0.04055 is your interest rate. So that is about an interest rate of 4.055%, okay, which is about what we got earlier, because when you're calculating a weekly compounding schedule, that's almost as good as continuous, so it's not too surprising these are very, very close to each other.